Hi Julian, thanks for joining me today to discuss the measurement of surface chlorides, which is such an important topic that impacts a number of productive coating specialists.
Hi Craig, thanks for having me. Completely agree. For a measurement result that has such a significant impact on the outcome, there still seems to be a fair bit of miscommunication out there.
Julian, you've worked right across Asia, both protective coatings and water jet applications. I'm sure you've seen a lot of different techniques and outcomes.
Sure, Craig. While the standards specified are the same, the interpretation and techniques used can vary greatly.
And now your focus is upon productivity, quality. What are the most challenging opportunities?
Well, to be frank, the priorities has always been about extending coating life. I see this as being valuable for reducing maintenance costs and maximizing asset return on investment. A key part of that, from an educational perspective, is quantifying actual surface chlorides by removing confusion on elements that impact coating life and natural elements that have no impact whatsoever. As with our Australian garnet source, which has natural occurring bonds with calcites and calcium carbonate, which is also known in the industry as a corrosion inhibitor.
So what's the relevance of a conductivity meter? Aren't they all the same?
Sure. However, there are significant variances found in some testing gauges. For example, on the pipeline job, we looked at the location. After considerable evaluation and the use of an ion-specific test using the sleeve for extraction was conducted to determine that the reading the coating inspector initially had were from the incorrect measurement of non-corrosive salts, such as carbonates, bicarbonates, and hydroxides. Whilst these elements contribute to the conductivity reading, there are non-corrosive elements that are typically in the makeup of natural almandine abrasive materials. As they dissolve in solution, these elements, when measured in terms of conductivity, will result in an irrelevant reading.
So you mean that even though these carbonates, bicarbonates and hydroxides are non-corrosive, they form part of the ISO 8502 outcome?
Possibly, as the ISO 8502-9 is not a measure of only chlorides, simply the soluble elements on a blasted surface. It measures the conductivity of both non-corrosive and corrosive salts. So once dissolved, all ionic elements register a water-soluble conductivity reading.
So to clarify, that means the total reading is an extraction of all elements, regardless of their corrosive capacity?
Yes, and in future cases, to assist with this, we will be able to follow the updated recommendations of ISO 8502 and verify the results by moving away from a conductivity test and refer to the ion detection tube analysis and sleeve extraction methods for measuring the chloride ions alone. Using the ion-specific test, the only field-ready method is using the ion detection tubes. These results have been found to be more accurate. And compared to the solubilization method, we found that the ion detection tube method revealed that the surface chloride measurements were not only within specification, but also vastly different from the conductivity or conductometric readings, which are confusing because the calcium carbonate, bicarbonate, and hydroxides are non-corrosive elements. The latest 2020 updates of the ISO 8502-6 and the -9 is a recognition by ISO that erroneous readings is possible by the irrelevant contribution of carbonates, bicarbonates, and hydroxides. So accordingly, alternative test methods such as the ISO 8502-5 and the newly introduced ISO 8502-15, which provides more accurate instructions and results for ion-specific contamination, should now be used as the primary preparation test method to ensure optimum coating protection.
So in summary, from where we transform to a sleeve method, using the ion detection tube to conduct a verifiable chloride ions reading. So when do we expect these changes to take place, and how will we work with them in the scope of the existing specifications?
Well, the updated relevant ISO standards have just recently been published and will clear up most of the misconceptions. From our perspective, we see that most specifications have an allowable tolerance of surface chlorides in the upper range that can be easily met through the normal use of ion detection tube and the sleeve test method. If we take a look at the raw abrasive measurements covered under ISO 11127, this then allows us to verify prior to surface cleaning operations that the abrasive is certified and will not contaminate the surface with any level of chloride ions.
Julian, thank you for your time and sharing these updates.
Thank you.